Welcome to all. Our topic is types of GIS data, that is spatial and non-spatial, vector and raster data. Before going to that, we should know about GIS. So a geographic information system is a computer system for capturing, storing, checking and displaying data related to positions on Earth's surface. So GIS can use any information that includes location, and the location can be expressed in many different ways such as latitude, longitude and address, etc. So many different types of information can be compared and contrasted using GIS, and the system can include data about people such as population, income or education level, etc. So with GIS technology, people can compare the locations of different things in order to discover how they related to each other. That is, for example, using GIS, a single map could include sites that produce pollution, such as factories and sites and that are sensitive to pollution, and such a map would help people to determine where water supplies are more at risk. Then next is the types of GIS data. The GIS data is broadly classified into two types, spatial and non-spatial. Then spatial data, it is a geographical representation of features. And in other words, it is what we actually see in the form of maps on a computer screen. These are further classified into vector data and raster data. So these are some of the features or characteristics of spatial data, that is grid coordinate, place name, postcode, distance and bearing, description, latitude or longitude. Then a common example of spatial data can be seen in a road map. That is, a road map is a two-dimensional object that contains points, lines and polygons that can represent cities, roads and political boundaries such as states or provinces. So a road map is a visualization of geographic information.
Among the two types of spatial data, the first one is vector data. They provide a way to represent the real world features within the GIS environment. It has its shape represented by geometry, which is made up of one or more interconnected vertices. And a single vertex describes a position in space using an x, y, and optionally z axis. This system of recording feature is based on the interaction between arcs and nodes, which are represented by points, lines, and polygons. That is, in the vector data model, the features on Earth are represented using three different ways. First one, points, second one, lines or polylines, and third one, polygons. Now we can see each one by one. The first one is points. They are used to represent the non-adjacent features and discrete points, that is, specific location of each geographic feature. They are composed of one coordinate pair representing a specific location in a coordinate system. Since they have zero dimension, neither length nor area can be measured by using this database. By definition, a point cannot be seen since it has no area. But in practical, when they are being mapped, the points are represented using symbols that have both area and shape. For example, circles, squares, plus signs are used. In the figure, the points are shown as circles and the coordinate pairs are given within the bracket. The another important feature of the point is that when they are zoomed in, for example, while considering the point location of school, when they are zoomed in, it is more realistically represented by a series of building footprints showing the physical locations of the campus. That is, when viewed at a smaller scale, they will appear as a single point, but when it is zoomed in and viewed at a larger scale, that single point will be comprised of a series of points indicating different locations within the campus. The second one is line or polyline. When two vertices are joined, it forms a line. When more than two are joined, it forms a line of lines and hence a polyline. They are used to represent linear features, example rivers, trails, streets, contours, footpath, etc. Since they are one-dimensional, they can only be used to measure length. In order to distinguish from one another, they are symbolized using shapes that have color, width and style. That is, different line types can be used like solid, dashed, dotted, and also different color combination with different thicknesses can be adopted. And these different color combinations may be indicative of attributes like whether it is surface of gravel, tar, etc. The special rules for polylines in addition to basic geometry include that the contour lines may touch, example at a cliff face, but should never cross over each other. And in case of road network, the polylines used should be connected at intersections of the roads. As you can see in the topmost figure, when viewed in a smaller scale, the polylines will appear as smooth, curved, most generally like a single straight line. But in the case when it is zoomed in, that is viewed in a larger scale, it appears to be very angular. The third type is polygons. They represent areas such as boundary of a city on a large scale map, lake or forest. They have a single starting and ending point and will be composed of 3 or more line segments. Since they are two-dimensional, they can be used to measure area and perimeter of a geographic feature. They often have shared geometry. That is, a common boundary will be shared with a neighboring polygon. They are distinguished using either a thematic symbology, that is different color schemes and also different patterns. The other main feature of the polygon is that they also embody the idea of an inside and outside. In fact, the area that a polygon encloses, that the area within inside the polygon, is explicitly defined in a GIS environment. If it isn't, then you are working with a polyline feature. For example, you can consider the figure given in the slide itself. Here, the 3 connected lines define a triangle. They can represent 3 connected dot segments. Thus, it becomes a polyline feature, or they can represent the grassy strip enclosed by the connected roads, in which case it comes an inside case, which implies defining a polygon. Among the 3 methods, that is points, lines and polygons, choosing the method to represent a feature is mostly a matter of scale, convenience and type of feature, that is depending upon the nature of the geographic system. Now we can see how it will be represented in the case of a GIS. The first figure shows a geographic system in which a lot of geographic features are there, like trees, houses, roads, rivers. In the second figure, we are representing all of them by using the vector data model representation. Here, the green lines or curves indicates the roads, and the rivers are shown by using blue lines or curves. The red points indicates the trees, and the white polygons shows the houses. Thus, the landscape features we are presenting in a GIS.
I'm Sri Lakshmi. Let us look at the advantages of vector data. The first advantage is that it requires less disk storage space. Why? Because here we store information in lines and points, and we only give value to the things that we desire. Unlike raster data, where information is stored in the entire cell, that is all the cells of the area, we have to give it a DN. So the second advantage is efficient for topological relationship. That is, it shows the spatial relationship between 2 features. It is efficient for showing that. Then it is easier to edit. It gives an accurate map output. It gives an efficient projection transformation. And lastly, the graphical output of vector data more closely resembles hand-drawn maps. And because the boundaries are well defined in vector data. Let us now look at the disadvantages of vector data. The first disadvantage is that it has a complex data structure. Unlike raster data, it has less compatibility with remotely sensed data. As we know, remotely sensed data is collected as raster data because it goes with remotely sensed data and it is easier that way. So that is an advantage of vector data. The next one is expensive software and hardware. And it is not appropriate to represent continuous data. Continuous data is better represented through raster data because throughout the cells we can show the graduation in value, whereas in vector data it is better to show discrete data. The last one is overlaying multiple vectors are time consuming. That's it. Over to the next slide.
Now we are coming to the advantages and disadvantages of non-spatial data. In case of tables, they are good at showing a large amount of data. Their another advantage is they are simple and effective. Values can be used for statistical analysis. Its disadvantages is they are having a little visual impact. In case of bar chart, they are ideal for categoric data. They are good at summarizing large data sets. They can estimate values at a glance. In case of pie chart, their advantages are they are visually stimulating, display relative proportions. Their disadvantages are they are hard to differentiate if numerical values are not included. They can be too complicated if 3D or too many data sets. In case of graphs, their advantages are they are ideal for continuous data. They can show correlation without needing to conduct statistical tests. Its disadvantages is correlation does not equal causation. In case of flowchart, their advantages are they have a good visual appearance, ease of understanding, ability to do statistical analysis if numerical values are included, ability to subdivide to show groups, ease of drawing. Their disadvantages are they are having the factors that affect the sequence are not always included. If alterations are required, then flowchart may be redrawn completely.
Next topic is raster data. Raster data is cell-based data such as aerial imagery and digital elevation models. Raster data is characterized by pixel values. Basically, a raster file is a giant table where each pixel is assigned a specific value from 0 to 255. The meaning behind these values is specified by the user. They can represent elevations, temperature, hydrology, etc. Then, advantages of raster data. Raster is the best way to score continuously changing values such as elevation, slope. Then, analysis faster and more flexible than vector for many applications. Rapid computations, that is map algebra, in which raster layers are treated as elements in mathematical expressions. Then disadvantages of raster data. It is especially difficult to adequately represent linear features depending on cell resolution. Then network linkages are difficult to establish. Then processing of associated attribute data may be cumbersome if large amounts of data exist. Then raster map inherently reflect only one attribute or characteristic for an area. Most output maps from grid cell. Then system do not conform to high quality cartographic needs.
Hello everyone, myself Tammu Pertin, and I'm doing my part as on non-spatial data. So let us throw some light on the introduction. So what is non-spatial data? Data that relate to a specific precisely defined location, or we can say the data which are often statistical but maybe text, image or multimedia. Like it can be represented in text, image and also in multimedia. But these are linked in the GIS to spatial data that define the location. Like whenever we used to find a location, we have to use this. And the non-spatial data are generally dimensional and auto-related. So regarding this, the word attributes come here. And what is attributes? If you say, then attributes are the non-spatial characteristics that describe spatial objects, and these are commonly arranged in tables where a row is equivalent to one entity and a column equivalent to one attribute. So let us come on its means and examples. Additional non-spatial data can also be stored along with the spatial data represented by the coordinates of a vector geometry or the position of a raster cell. And as I told that non-special data is also called as attribute or characteristic data. Here the word attribute comes. Attribute, as I told before, attributes are the non-special characteristics that describe special objects. And non-special is that information which is independent of all geometric consideration, like it's not dependent on other considerations. For example, a person's height, mass and age are non-special data because they are independent of the person's location.
Hello everyone, my name is Tinkur Musa and I'm going to do the conclusion of this topic. Spatial data is used for creating visuals, graphics and statics, etc. As we have learned spatial data, maps are a common practice of presenting spatial data as they are easily communicate complex topics. They can help validate or provide evidence for decision making, teach others about historical events in an area, or provide an understanding of nature and human-made phenomena. And as of statics, with any data, to truly make sense of spatial data and understanding what it is saying, we must perform some level of statistical analysis. This process will help us overcome answers and lead us to make better decisions for our organizations. Non-spatial data that can be related to specific, precisely defined location. The data often is statistical but may be text, images or multimedia. Relating the spatial component along with the non-spatial attributes of existing data. For example, census figures can enhance the user understanding and gives new insight into the pattern and relationship in the data of that otherwise would not be found. For example, name of the road, schools that we want to search, we can easily locate them. Raster data is used as background maps. As we have learned, the raster data, it is used in mapping. Examples for like aerial photograph and satellite images, and it can be stored in any format, for example JPG, TIFF, etc. We have also learned about the vector data. The vector data is at core of the most commercial GIS, and it is believed that topological data model must reflect and geographically of the real world and provides an effective mathematical foundation for encoding spatial relationship, providing a data model of manipulating and analysis vector based data. The vector data set is widespread and increasingly available for a variety of sources, including administrative, political, social and environmental data such as census, enumeration, districts, wards, counties, parishes, national parks, land use, land covers, geology and so on. Therefore, vector topological data sets are thus also at the core of wide range of application. Despite the vital nature of vector data model in GIS environments, It may have some limitations, such as analysis in complex data may be time intensive, which limits the functionality of large data set. Example, large data, large number of features, etc. Thank you.
Hello everyone, this is Zakir Hussain and I'm going to tell you guys about the comparison between spatial and non-spatial data. First we take spatial data. The data date defines a location. These are in the form of graphic primitive. Date are usually either points, lines, polygon or pixel. The spatial data include location, shape, size and orientation. For understanding spatial data, we take an example. Consider a particular square. The center of square, the intersection of its diagonal, specifies its location. Its shape is a square. Its shape is a square. The length of one of its sides specifies its size. The angle its diagonal make with, say, the x-axis specifies its orientation. Spatial data include spatial relationship. For example, the arrangement of 10 bowling pins is spatial data. Spatial data are generally multidimensional and autocorrected. Now, non-spatial data. The data date relates to a specific, precisely defined location. The data are often statical but may be text, image or multimedia. And the non-spatial data are linked in the GIS to spatial data. Date defines the location. Non-spatial data are also called attribute or characteristic data. Is date information which is independent of all geometric consideration. To understand clearly non-spatial data, we take an example. For example, a person's height, mass and age are non-spatial data because they are independent of the person's location. It's interesting to note that while mass is non-spatial data, weight is spatial data in the sense that something weight is very much dependent on its location. And it's possible to ignore the distinction between spatial and non-spatial data. However, there are fundamental differences between them. Lastly, non-spatial data are generally one-dimensional and independent. Thank you.